All right. Hi, everyone. Thank you for joining us today for the 10 questions to answer before deploying Postgres in the public cloud webinar. My name is Christy Anderson, and I'm joined by Ankur Srivastava and our CEO and database expert, Dharshan Rangegowda, who will be leading the webinar and discussion today. Dharshan founded ScaleGrid back in 2012 after spending many years with Microsoft, where he worked with their virtual machine manager and later became one of the development leads who pioneered Azure Connect's virtual networking service. For those of you who are meeting us for the first time, ScaleGrid is a database management platform that helps you automate your time-consuming database operations. This allows your DBA team to focus on the development aspects of maintaining and optimizing a healthy production deployment. So we support MongoDB, Redis, and Postgres and MySQL. We chose Postgres today because we've seen a significant shift in the enterprise space, migrating their legacy deployments to Postgres. So today, Dharshan will spend the first half of our hour walking us through the top 10 questions to ask and answer before deploying Postgres in the public cloud, and we'll reserve the second half for an open Q&A discussion. In the bottom right of your screen, you might see a chat window. If you have a question at any time, just enter it in here, and we will dive into it in the second half of our hour. So without further ado, I would turn it over to Dharshan.
Thanks, Christy. Thank you for the introduction. Hi, folks. My name is Dharshan. I'm the founder of ScaleGrid, and thank you for joining our webinar today. Over the past several years in ScaleGrid, we've deployed and managed thousands of database instances on various public clouds, and we have learned a few things along the way. And this presentation is essentially our way of sharing our learnings with you. On average, we are seeing about 40% of Postgres deployments are in the public cloud. And this number is accelerating every year. So if you are considering migrating your existing Postgres deployment to the cloud, or if you're doing a new Postgres deployment in any of the public clouds, there are a number of different aspects to consider, both functional as well as non-functional. And today we're going to talk about the top 10 deployment considerations you need to keep in mind as you move your clusters to the public cloud. Let's start with high availability. High availability is an important requirement for all production applications. Essentially, what it means is that the loss of a single instance should not bring down your database. Before we get into the details, let's start with some Postgres replication basics. So in Postgres, you can have a standalone deployment, or you can have a master-standby deployment. And standalone deployments, typically, they are good for, it's a single machine, and they are good for typically dev and test deployments. And you should never deploy a production system on a standalone deployment. And with master-standby deployments, typically, you can have a master and a standby, or you can have a master and multiple standbys if your application is able to read from the standbys and you need to do read scaling or things like that. Typically, when you have a master standby setup, you have set up streaming replication between the master and the standby. And essentially, every change the master makes is returned to the write-ahead log of the WAL. And the standby is continuously downloading these WAL entries and applying them so that they can stay in sync with the master. And you can be doing async or sync replication. Both of them work fine for Postgres. Now, getting back to the high availability, essentially, like we talked about before, you don't want to run a production instance on a standalone machine. There really is no SLA for a single instance in any of the public clouds. What you want to be doing is you want to be running a master standby setup. And we recommend a 3-node setup, a master and 2 standbys. And essentially, what you want to do is you want to distribute these instances across different availability zones. So for example, in AWS, we recommend you choose a region that has at least 3 availability zones. And you put each instance in a different availability zone. And the reason you want to do that is all the availability guarantees are across availability zones. So by distributing your instances across different availability zones, even if one zone goes down, it does not impact the availability of your application. Azure similarly has the concept of availability zones. And it's a new concept in Azure. They did not have it starting out. So some of the regions have availability zones and some don't. If you're in a region that supports availability zones, I would highly recommend you use it. And if you're in one of the older regions that don't support availability zones yet, you can use something called an availability set. It's a slightly weaker guarantee than the availability zone, but it will ensure that your replicas are distributed across fault domains and they go on different racks and things like that. Once you have high availability handled, the next thing to look into is disaster recovery. Disaster recovery setup is, at least an order of magnitude more complicated than high availability. So the first thing that you need to do, as you and your team need to understand what are your requirements from an application perspective. For example, what is the expected behavior from your application when the entire data center goes down? For example, let's say you're running in US East in Amazon and US East goes down. Is there an expectation that your application still continues to keep running? And next thing you want to figure out is, do you want the recovery to be automatic or manual? Is it okay to have some manual steps when an entire data center fails, or does the whole process needs to be automatic? And once you have identified the answers to these questions, this gives you more of a requirement around what is it that you need to set up for disaster recovery. If you need automatic disaster recovery in the public cloud, the only way to do it is to basically distribute your replicas across different regions. And you will need a minimum of 3 regions. You can do it with 2, but it will work for some cases, but it will not work for all cases. So our recommendation is, distribute your replicas across 3 different regions. And in each region, you can set up a VPC or a VNET. And in AWS, you would set up a VPC. So set up a VPC in each region, and then set up VPC peering across the regions. So this will make it easier for communication across the different regions. And when you have a setup like this, even if an entire region goes down, the 2 remaining regions will elect a new master. And essentially, your system will not have any downtime. However, disaster recovery, like I alluded to before, is a lot more complicated than high availability. So there are many aspects to consider. For example, latency will get very interesting during failover. For example, let's say your primary is deployed in AWS US East, and there is a US East goes down, and then you fail over to US West. So at this point, the latency is fairly high for your application, and you want to make sure that your application setup can handle this latency. Also, when you're working across regions, the AWS security groups don't extend across regions. So essentially, your team will have to do all the firewall management using IP-based CIDRs or whitelist. And this makes things much more complicated. And also, your data is moving across regions. So there's definitely increased cost on your end because you're paying for the data egress fees. The next question we want to deal with is performance of your instances once you deploy in the public cloud. AWS provides like a wide variety of instance types that you can use for your database servers. You have memory optimized instances, disk optimized instances, CPU optimized instances, balanced instances. Based on our experience, what we would recommend is to start with the memory optimized instance types. Databases are essentially a RAM and a disk game. You want to have as much RAM as possible, and you want a fastest disk as well. So in our experience, we have found that it's best to start from the memory optimized instance types. In AWS, that would be the R5s and the R4s and the R3s. Start with that, and you can do some performance testing. And if you find that you need more CPU, you can move towards the balanced instance types or the CPU intensive instance types. If you find that you need more I/O, you can move towards the disk intensive instance types. Whatever instance types you choose, please ensure that you have enabled the EBS optimization for this instance type. And EBS optimization essentially creates separate channel for your application network traffic and your disk network traffic. And this gives you the best performance on AWS. And you also have to ensure that any type you choose has enhanced networking. And typically, if you choose to deploy in a VPC, this is enabled by default. AWS also gives you like multiple options for disks. The default is usually the EBS standard disks. With standard disks, you get about 3 IOPS per GB. So for example, if you choose to deploy like a 1 terabyte disk, you will be getting about 3,000 IOPS. And the standard disks work fairly well. And it's important to understand the I/O characteristics of your application. For production applications, we would recommend, instead of going with EBS standard, we recommend you go with EBS provisioned IOPS. The reason is with EBS provisioned IOPS, you have more fine-grained control over what IOPS you can apply to your disk, and also you can change it dynamically based on your needs. However, EBS provisioned IOPS are, they get very expensive, and for a lot of our larger customers, the provisioned IOPS are a bigger part of their bill than the instance cost. So that's something to look into. And third type of disk available in AWS is very interesting. It's the local attached NVMe SSD. And this is the best performing disk in terms of throughput as well as latency in AWS, but it comes with a catch. Essentially, the disk is a ephemeral disk. So if you decide to stop your instance, this disk goes away. So you have to be very careful about how you use the local attached SSDs. In ScaleGrid, we have a special queue which we call the high performance queue. And the way we set it up is we have a 3-node setup, a master and 2 standbys. And the master and the first standby, they are on NVMe disks. And the second standby is on an EBS disk. So essentially, you get the best of both worlds. You get the best performance out of the NVMe disks. And you also get the data safety you get from EBS disks. And in that configuration, one thing you want to watch out for is you want to closely monitor the replication lag on the EBS disks, because the EBS disk might not be able to keep up. So it's important to monitor the lag and either increase the IOPS or the size to ensure that the particular EBS disk can keep up with the SSD disks. Azure is fairly similar as well. Just like AWS, it has, Azure has a whole alphabet soup of instance types, ES v23, ES DS2, and there's a whole bunch of instance types that you can use. But our recommendation is fairly similar. Start with the memory optimized instance types, typically the ES series, and work your way based on your tests after that. In terms of disks, Azure also offers multiple options. There are essentially at a high level, there are 2 types of disks in Azure. There's managed disks as well as unmanaged disks. And unmanaged disks are the legacy disks in Azure, where you have to set up the storage account and map your disk to the storage account, and you have to worry about the IOPS limit per storage account. So we highly disrecommend using unmanaged disks. Unless you have a specific reason, you should be just using the managed disks in Azure. And with managed disks, you have multiple types of managed disks. The default is the standard disks. And these disks are typically good for dev and test operations. You can resize them dynamically, but they only go up to 500 IOPS. So we don't recommend using standard disks in production. If you are deploying a production database server, on Azure, we highly recommend you use the premium disks. And there's a whole variety of premium disks, and you can choose your size. And for each size, there is different IOPS, so you can choose the size that works for you. Azure also provides the local SSD option. And these disks, again, are very high performant in terms of I/O. And they also have the same drawback as EC2, essentially that they are ephemeral disks. So if you stop them, the disk goes away. And we have run a number of performance tests with the Azure local SSD, typically with the LS v2 instance types. And we have the performance has been fairly disappointing. And the reason is that the LS v2 series, they have a really weak CPU. So even though the disk is really fast, your machine quickly bottlenecks on CPU. So that's something to think about as you play with the local SSD. Let's talk about backup. There are multiple ways to back up your data on the public cloud. And the simplest option is to go with the logical backup. And you can use pgdump all. And this is the simplest option, but it's also the slowest. And essentially, your backup time depends on how much data you have, and it's directly proportional. It'll keep increasing as your data increases. So the logical backup technique doesn't scale as your data grows. And typically, most Postgres users use an advanced specific tool for backup, like PG Backrest or Barman. And these tools work very well in the cloud environment as well, so you can continue to use them. Public clouds give you another interesting option for backup, which is the volume snapshots. For example, if you are on AWS, you can use EBS snapshots to back up your data. And the EBS snapshots also have the interesting property that they are diff snapshots. So they only store the difference from the previous snapshot. So if you have like a large 3 terabyte volume and you're taking multiple snapshots, it's not storing 3 terabytes every time. It's just storing the difference between the snapshots. And once you have snapshots, you can also use it for other scenarios like clone. For example, let's say you want to clone your production Postgres deployment. You can take a snapshot of your production server and use that snapshot to seed a clone. Azure Managed Disks have a similar option. You can take snapshots, you can use them as well. There are multiple ways to set up your network in the public cloud. And there is the traditional classic shared LAN where essentially everybody is in the same address space and they are getting a network in that an address in that address space. And then there is the SDN option of VPC and VNET. And we highly recommend you go with the VPC option. And you should not be using the classic shared LAN unless you have a real particular reason you want to use it. When you set up a VPC or a VNet, and this is basically the software, it's a VPC in AWS and VNet in Azure. It's a software-defined network. You can bring your own address space. You can create different subnets, public subnets, private subnets, and you can configure routing rules between the subnets. And for databases, we typically recommend you deploy them in your private subnet. And you can also set up firewall rules based on this routing. And you can also set up automatic VPN connections back to your corporate, so it integrates very seamlessly with your existing infrastructure. And so so our recommendation is if you're deploying anything new on the public cloud, you should definitely be deploying it in a VPC or a VNet. Once your system is up and running in the public cloud, you're probably running your database instances 24/7, 365 days a year. And public clouds, if you're in that scenario, public clouds give you a lot of options to save money. For example, on AWS, if you're running your instances all year, you can purchase something called reserved instances. With reserved instances, essentially what you're doing is you're telling Amazon that you're planning to run these instances for a year or 3 years. And because of your commitment, Amazon is going to give you a reduced pricing. So for example, in AWS, you can buy a 1-year reserved instance, or you can buy a 3-year reserved instance. And obviously, if you buy it for 3 years, it's much cheaper than 1 year. And typically, if you buy a 1-year reserved instance, you can save up to 30% of your compute costs. So the reserved instances only apply to the compute cost, and they don't apply to the disk, like EBS provision IOPS and things like that. And typically, you purchase reserved instances for an instance type and for a region. So you can deploy these. Let's say you buy a reserved instance in a particular AZ, you can move it to all other AZs across the region. So there is no issue with that. However, you are not able to move your reserved instances across regions. So for example, let's say you decide to purchase reserved instances for AWS East, and 4 or 5 months down the line, your company decides it wants to move to US West. At that point, your reserved instances will not port over. So that's something to keep in mind as you purchase reserved instances. There's also another caveat here. Typically, when you purchase reserved instances, you need to specify the instance type for which you're purchasing reserved instances. And what happens down the line, let's say 2 months from now or 3 months from now, when there is a new instance type that you want to use, or AWS releases a new version. By default, it's not portable. So you are tied to the instance type to which you reserve. But AWS does provide another option called convertible reserved instances. So if you purchase a convertible reserved instance, then if you want to change your instance type, AWS will give you the option to move from the old instance type to the new instance type. So if you expect to change your instance types over the year, it might make sense to purchase convertible reserved instances versus non-convertible. Security is a really deep topic, and we could probably do an entire presentation just on security. However, we'll just touch upon some high-level configuration that you can do that will greatly increase the security of your deployment. And like we talked about previously in the networking section, you should definitely be using a VPC for your deployment. You should have public subnets and private subnets. You should deploy your applications in public subnets, and you should deploy your databases in a private subnet. And once you deploy in a private subnet, typically what that means is that the databases are not reachable from the internet. There's no routing to them from the internet, and that makes it much safer. Also, try to leverage the built-in firewall configuration that is provided by the cloud vendors. For example, AWS provides security groups, Azure provides VNET security groups, and you want to use these firewall configurations and lock down access to your database on a need-to basis. If you need to expose your database to a public network, make sure you enable SSL, essentially for encryption in transit. So all data going to and from your database should be encrypted. Based on your compliance requirements, you might also need to do disk encryption at rest. And typically, when you do disk encryption at rest, your backups are also encrypted. Both AWS and Azure, they have native support for disk encryption. So if it is something that that you need to do based on compliance, I would highly recommend to look at the native encryption options provided by AWS and Azure. Once your deployment is up and running in the cloud and things are going very well and your load keeps increasing and you're ready to scale, public clouds make it really easy for you to scale your deployment. You can scale your instance type, and what that means is you can scale up your RAM and CPU dynamically. You can scale your disk size, you can scale your disk IOPS, and essentially this is where public clouds, they really beat any sort of physical hardware that you can deploy, and they make it really easy for you to scale in place. And typically how it would work is you would do a rolling operation. So for example, let's say you have a master slave setup. You would take down the slave, change the instance type to the new type that you need, increase the disk size if you need to, change the IOPS, you would need to bring it back up, wait for it to sync up to the current master. Then you would do a failover from the current master and make the old slave the new master. And then you would repeat the process with the old master. And essentially this way you can do a dynamic in-place scale with no downtime. And the only disruption your application will see is that it will see a failover of the master from one node to another. You can do a change of instance. In order to change the instance type, you need to stop the instance and restart the instance. You cannot do it online. But if you want to change the disk size or if you want to change the disk IOPS, you're typically able to do it online. For example, in AWS, if you have a GP2 disk, you can resize it online. If you have a provisioned IOPS disk, then you can also change the IOPS for the disk based on your needs. Similarly, Azure also enables you to resize managed disks. The only caveat on Azure is that you cannot resize the disks online. So essentially, you have to stop the instance, take the disk out, resize it, and then attach it back. Upgrade is a very interesting topic with Postgres. And unfortunately, the upgrade operation with Postgres is not as seamless as some of the other databases. So you don't have a way to do online upgrade. Typically, when you're doing a major version upgrade, you have to take some downtime. And typically what happens is, you will shut down all the nodes, and you would run a PG upgrade operation on the master. And once the upgrade operation on the master is complete, you will rebuild the standbys using the new master. And the cloud providers, they provide some features that will help you with this. For example, you can use volume snapshots to easily rebuild the secondaries. So for example, let's say you did a PG upgrade operation on the master and it is ready. So you could quickly take an EBS snapshot. And EBS snapshot, again, they are diff snapshots, so they only copy the difference. And then you could easily rebuild your standby using these snapshots. And there's all these snapshots are zero copy operations, so there's no data moving around as you build a new volume from a snapshot. So even if you have a really large volume, let's say a 10 terabyte volume, the time taken to take a snapshot and to rebuild a volume from the snapshot is the same. So essentially, you're able to rebuild your standbys without any network copy. And this makes it really useful as your database size continues to grow. Lastly, once your system is up and running, you want to make sure that your system is monitored correctly. And it's very important to have a continuous monitoring of your database deployment in the public cloud. All your existing tools will work fine. Cloud providers also give you a lot of monitoring tools. So make sure all your OS metrics are captured from CPU usage, RAM usage, disk usage, disk queues. And you should also be monitoring all the Postgres metrics as well, from the count of the operations, from any WAL usage to connections, replication related metrics and things like that. You should also keep an eye on the health of your queries. So you should be looking at which queries run frequently, which queries run slowest, which queries are scanning the most documents. Now in ScaleGrid, we have built some custom UI to essentially show you a heat map of all these queries. But even otherwise, you can use pgstat statements to monitor the health of your queries. And that's it. So we have shared the top 10 considerations while you're deploying Postgres on the public cloud. I think it's time to move to questions at this point.
Thanks, Dharshan. That was actually very informative. So if you have, I see that there's a bunch of folks on the phone as well. So if you guys have any questions, feel free to, I don't know, Christy, if we can unmute the attendees. But if you have any questions, you could either type it in the chat or you could speak as well. So happy to do that. I think we're getting one from maybe Madan Kumar. So let's see what Madan has to say. And so, Dharshan, obviously, this was extremely helpful from what we've been seeing. One of the things that you may want to talk about is essentially the ScaleGrid value add in the scope of these deployments that most of these customers are taking on. How are we able to accelerate that, just beyond just some of the pain points that we've identified?
Sure. Thanks, Ankur. So essentially what we have at ScaleGrid is we have a platform that will handle all the operations aspect of running your production Postgres server, starting from deployment, high availability, backup, restore, scaling, query analysis, patching, upgrade, monitoring, alerts. And essentially the goal with our platform is for our software and for our team to essentially handle all the operational aspects of running a production Postgres server, so our customers can just focus on the application aspect of things.
That's right. So, one of the biggest pain points that we're solving for over here is the pain point of today you are going through this modernizing of your architecture from legacy environments to, let's say, Postgres, and then let's say if you're even setting it up on your on-prem system and then eventually moving it to different cloud providers, you still have to have the nuances of those cloud providers or even the internal infrastructure, private cloud infrastructure that you're basically having to ramp up and learn. We're basically able to create layers that allow you to seamlessly move across those environments, and essentially you have the benefit of leveraging all the tribal knowledge that we've aggregated and not be locked in to any of those vendors as well. So it's a nice little insurance policy. Would you agree with that?
Definitely. And our goal is to basically handle all your Postgres related questions, so you don't have to worry about them.
That's right. So now there is one other thing that we do really well, and I saw Madan's question, so Madan, I'll bring that up in just a moment, so thank you for asking that. We are also able to come in and do a little bit of an advisory service where we'll work with you guys to help formulate a plan for that migration, the imminent migration that you may be considering. So as you can see, we're starting to see a lot of use cases around this transformation that's taking place. And with the help of obviously the solution that we have, we're able to not only answer a lot of the questions, but expedite that journey as well. So a question from Madan Kumar is, from a security perspective, do you suggest lockdown from Postgres side, PG_HVA, or cloud vendor side? Since in some of the scenarios you mentioned involving VPCs, security groups may not help in the DR scenario.
Yeah, I think it ultimately depends on your scenario, and the requirements in a single region deployment will be different from a multi-region deployment. So again, it depends on your address space, and based on your requirements, you might need to lock it down differently. And we are happy to go into the details and if you have specific questions, work on that offline.
That's right. Thanks. Another question is, does one cloud provider provide a benefit over another?
I think this is a really interesting question. And ultimately, I think it's an organization-wide decision. And typically, if you're an organization, you have opinions on which cloud to use. For example, a lot of customers already have relationships with Azure, with Microsoft, and they gravitate to Azure. However, a lot of customers, are using AWS, and AWS is kind of the default cloud provider. And a new trend we are seeing is multiple cloud providers. Organizations, they don't want to put all the eggs in one basket. So essentially, we are seeing people who are deploying, who are distributing their deployments across multiple cloud providers. This way, they are not tied to any particular vendor.
Right.
So the short answer is, it depends.
Okay, great. Next question from Madan Kumar is, do you recommend hybrid cloud deployment, pros and cons of those?
I think hybrid cloud deployments are very interesting. And a lot of the existing enterprise customers are starting to look into it. And the VPC models and the VNET models I alluded to earlier, they fit very well in the hybrid cloud deployment model. So essentially, you could have some nodes on-premise, and you could have some nodes in the public cloud as well. And that's where the hybrid part comes in. But essentially, a lot of these customers are using this as a sort of a temporary situation before they migrate completely into the public cloud.
Great. Another question that we have is, should we upgrade before or after migrating to the cloud?
I think this is an interesting question. And typically migration is a fairly involved process. So I would highly recommend to not couple this with anything else. So for example, if you are considering migrating to the a newer version, just from a simplicity perspective, it might make sense to complete that migration before you start thinking about any sort of public cloud journey.
Got it. And then the last question we have, Dharshan, is what's the difference between RDS versus ScaleGrid?
I think there are a number of differences with RDS and ScaleGrid. And the first one is, there is a difference in philosophy in how we have built it. And RDS is essentially like a black box. it works very well, but why it's like a black box and you have very little visibility into what is going on. And if you want to tune certain things, you don't have a lot of visibility into it. And ScaleGrid is designed from the sort of an opposite philosophy, and we give our customers, root access to the underlying machines, as well as super user access on Postgres. So essentially, you can, if you want to deploy any extensions, you can do that. If you want to tweak any settings, we are happy to work with you on that. If you want to tweak collation settings, that's something we can enable as well. So while we manage the entire life cycle, we have it open and configurable. We can also support, different instance types. RDS is fairly limited in how in the instance types it supports. But for example, let's say you want to use the SSD disk optimized queue of, the i3 SKU, you can do that with RDS today, but you can do that with ScaleGrid. And there are a bunch of other differences as well. And we'll, when we follow up with the attendees, we can send them a link where we give the comparison in detail.
That's great. And then another question is, if we're considering migration from Oracle to Postgres, how does that process look if we're also migrating to the cloud?
Yeah, I think it's just similar to some of the upgrade questions we did before. Mm-hmm. And I think it's a fairly detailed process. So you want to take it one step at a time. And we are happy to engage with customers, look at their deployments, and give us some suggestions. But essentially, what you need to do is you need to have a plan. So if you're migrating off Oracle, and typically what we recommend is, there are a whole bunch of tools. There are a lot of consultants we work with. We have a number of partners who help with this scenario. And essentially, you can set up continuous replication from your Oracle server to your Postgres server. And we recommend you set this up and you let it run for a few months at least. And so you can point some of your applications to the Postgres servers, and you can determine if there are any issues with replication, if there are any application level query issues. And only once you're comfortable after a few months that there are no sort of application level issues, at that point you can flip the switch on the cloud migration.
Excellent. Well, that's pretty much all the questions that we had. And so Dharshan, thank you so much for taking the time to answer them. I'll turn it over to Christy for wrapping up, but and to all the attendees obviously as well. So thank you so much for joining and listening. If you have any questions or you'd like to engage Dharshan, myself, and Christy for a deeper dive into your upcoming scenario, we're happy to go back and or happy to jump on a call and have that discussion with you and go into detail as well. Christy, I'll turn it over to you for a wrap up.
Thank you both. Yeah, like Ankur and Dharshan had said, we kind of covered everything at a high level here, and we're here to help. So, if you do want to have a discussion, feel free to send us an email at sales@scalegrid.io or send us a note through our website, and we'd be happy to set up some time to set up a discovery call, a confidential session to help you plan out your migration. And I also opened it up in case anyone wants to chime in with a question that wasn't posted over the chat. Otherwise, we will be continuing these webinar presentations, and we'll make sure to let you guys know when we have our next one scheduled.
Excellent. Thank you so much, Christy. And I did know that some of them did mention if we'd have this presentation available for internal distribution, we can make that available, or we're happy to actually do a more personalized presentation based on your scenarios. So we'll have our business development team reach out to you. I think one of those questions came with Farouk. So Farouk will reach out to you from our team and schedule some session to have that discussion directly with you. Thanks, everybody. Have a great day, and thank you again for listening to our session. Appreciate it.
Thank you.